coming, we'll let him formally introduce himself as an intern. So, Jeremy?
Thank you for coming to my internal internship project overview. And my name is Jeremy Worcester. This summer I worked in the OCS department, and I also had a personal project. I'll get into that here. My internship is divided into two components. I have the part where I work with OCS. That's 80 hours of job shadowing, and then the goal of which is to just become more acquainted with working in a real IT field and seeing what my department actually is like after I get out. And my project is a minimum of 40 hours. It could be several projects or one big project. I had 3 separate smaller projects this time. And so that's a minimum of 40 hours working on all that together. The goal being, this time is especially assigned that Mrs. Todd and Dr. Nelson wanted me to develop my server management and set up some various platforms. And we also wanted to produce some tools for new students in the CIS department, imaging tools so that they could image their computers quickly. And we also wanted to help the lab as far as get some new hardware that might increase performance and stuff. That would be with the network time server, which I'll talk about later. So, job shadowing. So for 2 days a week, 4 hours on each of those days, 8 hours a week for 10 weeks, I did my 80 hours working in OCS. I would, for the first hour or so, I would kind of like answer phone calls and help people who came in during that time, and we would and just kind of get everything settled for the day. And the rest of the day was usually focused on some sort of project that was going on. The most significant project was actually the new building, of course, and there was a lot that went into making that building. There's a lot that goes into that. I had some networking skills that I learned in my networking class and in hardware with Mrs. Todd and Dr. Nelson, but actually I really had no idea what goes into creating a network infrastructure of this size. And so I learned a lot as far as it makes me appreciate what it takes to just be able to come into work, get on a computer and do something. That there's a lot of work that goes in there. It's all simple to do, really, just running wires, but it's all long wires, and there's a lot of them. The new building, I believe, has over 300 network connections that you have to run and terminate both ends and make sure they're all working properly and they're within code and they're not near power. And there's a lot that goes in making that. So I really appreciate how that works. So with my projects, as I already said, I wanted to, Dr. Nelson and Mrs. Todd wanted me to be able to help me like develop my skills with like server setup and management, and also to provide new tools for new students coming into the CIS department for imaging their machines. And we also wanted to improve our internal network. So the first server I did a Windows deployment server and a Linux-based imaging server, and I also had a network time server that was to be based off of a Raspberry Pi, using it with a GPS to get its time. So it's a very high level, it's a Stratum 1 layer NTP server, which I'll describe more later. So challenges setting all this up. Oh, there were a few. The summer, actually, I found out maybe not be the best time to do your internal internship, because sometimes I would come into the building and the buildings would be locked, and public safety isn't always around on weekends to unlock the doors, so I couldn't always get in to actually work on my project. So that was a challenge, but I eventually figured out when they were there, when I could come in, got that worked out. And also, as you remember, like we had a lot of storms this summer, a lot of rain. And so when you have storms, you have power outages. And power outages, the internal network goes down. And so up to this point, I've had 0 experience with Windows Server and restarting our network. And so there's a few phone calls and a few emails to Mrs. Todd asking, how do I turn on the network? So, but she gave me some pointers, and after a while I figured it out. And assuming nothing bad happened, like it's not very hard to restart the network. So there's a couple times I had to restart the network and get things going so I could work on my project. And one of the other major components of the project, it needed to be kind of off to the side of these imaging tools, somewhere out of the way, so new students could come and plug in the machine directly to a switch and just image their computer and to see how that process works. And so I had to like set up my own network basically to do that. And I had some experience previously with the operating systems class I had before, but I had to set up, I used PFSense on a PC. I set that up as a router and I had my own switch, and that way I was able to get like a different sort of separate network so I could do all my work that way. And so there were some challenges with PFSense I hadn't encountered before, but I got through those pretty easily after a few hours, so nothing major there. So onto the Windows deployment server. So I use Microsoft Office, Server 2012 R2, and overall, like installation, it was a little confusing at first actually. I had a hard time finding the hard drive drivers for the operating system to install, and after a while, they just magically showed up. I don't know where they came from because I tried a few. I tried downloading a few, putting them on there, but it wouldn't recognize them, and then it recognized it, so I just went with it. I wasn't going to ask it why, it just worked. So, but besides that, configuration and setting up the Windows deployment was very turnkey. I was very surprised. I had no experience with Windows Server up to this point, but I watched some videos and read a couple tutorials, and you just turn things on and then it works. And I was very surprised and very pleased, and I can demonstrate all these things, this and other parts of my project to you later. Performance, it's pretty quick. It's not the quickest I've seen, because all it really does is just make an image available for your machine to boot off of and then install from. So if you have a slow computer that's installing Windows, then you're going to have a slow install experience. But as far as streaming the image over and actually like initiating the service, like it was pretty quick there, but it wasn't like blistering fast or anything, but it wasn't too bad. So here's a screenshot I have. This is showing that I have a Windows deployment server. There's an IP address and put on there. Here's a list of some of the images I installed. I had three images from the CS department I used. I had a Windows 8 x86 and a Windows 7. I had a Windows 7 x86 and a Windows 7 Windows 8 64-bit, and so but they all have like different versions available that you can pick from when you install. So that's all those listed there. And so I pixie booted off my machine. It downloaded, like I saw the server. Since I have an x86 and an x64, there's two different setups I can choose from here. I picked the 64-bit one for whether it loads and it starts setting up. So everything's fairly typical. This actually was my only real issue I had with Windows Server. I didn't know the syntax for authorizing the use of images, and for this, because it's a standalone server, it's not on domain, I didn't have a domain set up or anything. I eventually just found out all it was just it's the host name of your server, and then like a user on that server who's authorized to use those images, and then it's the password for that user. So after I got that, it's pretty simple. I can demonstrate all this later if you like, in person. It's a little noisy in there, but it won't be too bad. So onto the Linux imaging server. I used FOD project imaging server, and I used, for my base system, I used Ubuntu 12.04, long-term LTS, long-term support version. It's a little old in Linux, like as far as Linux goes. It's kind of, they're up to 15, I think now, but I wanted to use something I knew would have like no issues, is really rock solid, and all it does is just deploy, so it's not really going to be used for much else. I want something that was very little bugs and all that. So configuration installation on that was pretty simple, straightforward. I've had quite a bit of experience with Linux in the past, so there was nothing going on there. I had one issue, which was weird because the service worked. I was able to log in, I was able to image, Then I turned it off. I messed with the Windows one for a while, then I turned it back on and it wouldn't work after that. There is a network service called TFTP that would hang up consistently upon rebooting, and I couldn't figure out for a while, so I looked it up and I found out it's actually just a known issue that occasionally some people who have this will run into that issue. And what I found was a script that I can insert into my startup configs that would delay TFTP by 30 seconds after everything else I'd gone through. And so after I did that, everything's fine. These servers are kind of, they're not old, I wouldn't say, but they're slow turning on anyway, so extra 30 seconds doesn't get much of an issue. So, but aside from that, the Linux imaging, I was completely blown away by how fast it is. And it's a little different from Windows, because Windows, will have the image available to install from. With the Fog Linux deployment imaging, whatever, it will pull a working installation off a machine, and then it'll store that image, and then when you want to deploy it, it simply just copies it all over and clones it. Like, it copies a clone and pushes that clone out to your machine. Depending on the size of your image, I had some pushes and some clone working, start to boot. I was done within 5 minutes on the machine. I'd have Ubuntu on it, and then 5 minutes later I had Windows 7, and then 5 minutes later I had Windows 8. It's insanely fast. Because it's a gigabit network, I was getting traffic speeds peaking at 34 megabytes a second. The average was 15 to 20, but it was peaking very high, 10 times faster than your regular broadband internet. It was just insanely quick. And so here's my Ubuntu 12.04 interface, and I changed that view later so you get more screen. But Fog is actually web managed, so you have just a username and password you get in there. Here's a dashboard showing you just did a whole bunch of imaging that day. It shows you how much space you left on your disk for images and information there. So here's a list of the images I made. I had a test Windows 7 install, an Ubuntu, Windows 7, and a Windows 8 right there. And these are the hosts. This is what I was talking about as far as pulling and pushing out images. You can assign tasks to do that with these arrows here. When you push the upload, these are upload buttons, it'll pull and extract that image. Next time that machine network boots, it'll extract the image that's currently on there. And then if you do the push, the next time the network boots, it'll automatically just shove the image that you've assigned to that host on there. And so here's the typical network boot. Here's the base thing that comes up. And one thing about it, it's a little more complicated than the Windows, because you actually have to register with the server and then get an image assigned to you. That's what the web side is for. But if you don't want to do that, the easiest way is just to delete your host and then re-add it back with the image that you want. So I'll show you some of those pictures. To delete it, you have to put the password and username in, and then you re-register and just pick your image you want. And then after you put that in, it just pushes out really quick. It's the general look. It has a blue background, orange progress bar. So previously that computer had Windows 8 from my previous installation. Now it has Windows 7. It was very quick and snappy. So finally we'll get to my NTP network server. Okay, so I use a Raspberry Pi. It's a credit card sized computer. It's the exact same one Milos used last time for his project. That's what it looks like. It's actually about this big. So those pins on the top there, you can use for different devices or to add on little hats on top. And so mine was a GPS hat. I can show you that. It's in the lab right now. And it runs Raspberry and OS. Now, what it's supposed to do, it is supposed to be a Stratum 1 network time server. And so the stratum indicates what layer below or above, it is from an atomic clock. So an atomic clock is a strata 0. It keeps time. It is official time. And so everything below that gets a number added to it. So you can have up to stratum 7, I think, is the lowest stratum. And so they're all like very accurate, but they get their time from the higher strata going up the chart. So we wanted to make a highest level possible NTP server for our lab to keep time, like have more accurate time, keep the traffic moving a little better. We had some performance issues in our network last fall or last spring, and so we wanted to use this to improve it. So actually, I was able to install and get everything to work. It does work. I have some screenshots I'll be showing you, and I can show you in the lab if you like, but actually, it doesn't work completely right. After restarting the network time service, what it'll do is it'll have a really low jitter, really low like offset from the real servers, like the GPS satellites. That have low numbers there, which is good. But if you leave it like for a day or two, like the offset, like you get giant numbers, giant negative, giant positive. Like it has a wide range of numbers that it'll just show it's happening there. And this thing took me almost about half of my entire project time just trying to get it to even do that. There were problems, like I had several sets of instructions for wide ranges of hardware and for older kernels than what I was actually using, and that they've been changing the Raspberry kernel to have support for these types of devices and these types of operations, but they're still not fully set to do that. And so most of my time was spent trying, reinstalling, resetting, installing, configuring. And since this computer, it's obviously, it doesn't like have any heat sinks or really anything on it, it's pretty slow. It doesn't move very fast. And so like I could, downloading and installing like some configuring could take up to 40 minutes just for one portion of each set of instructions. That's why it took me so long. It was very frustrating. But I did get it to actually work. It does have access to the GPS satellites, which I'll show you here. So there's a Pi there. I have it set, it's headless, so all it has is just power, and it has the GPS, and it has the Ethernet on the network. So you log in up there with PuTTY, and okay, it's kind of hard to see, I imagine it'd be this hard to see. I put out a query for all the time sources and what quality of time sources. And so up here it says it's the GPS right there, and so the offset's -500 and the jitter is like +43, which is everything else below it's either like up to -10, down to -10, or up to like maybe +2, +5, and that says like it's 43, and that should not be like that. So what I did here, I stopped the service, the network time service, and all this right here, all this random information here, that is actually information coming directly from the GPS. And so I did a query on the GPS. This is a little more easy to read if you're closer. Like it has a 3D fix. It's showing my altitude. It's showing the time offset, which is very low. It's a 0.7 right there and everything. So I know the GPS works. It has a 3D fix. I can get all the information. And when I start NTP, back up again, that requery, now my offset and jitter are gone down to 0, flat, which is impossible because they're not atomic clocks. Getting the information from atoms, so that's impossible. And then I ran that command, that query again a few more times, and after a while it catches up, figures out, and it has a really low jitter of 0.004. It's what you're looking for. Anything that's coming from a GPS should have much lower numbers than your regular NTP, like friends that ask for the actual time frame. It should have a very low jitter, very low offset, and it's working right there. It has that low jitter number right there, but I couldn't make it actually do that consistently, simply because there's too many changes in the latest kernel. No one's done it very recently, and so I couldn't. I tried finding just actual images of people who had it working, and none of them would actually work with my hardware that I could find out where everything was, change those configurations. But so, any questions about all that? I can show you more of this information around, but if you have any questions, I'd be glad to help you understand this.
So yeah, working along, what do you think? better to use Fog or Windows deployment server?
I'm not
Which one did you
sure.
like better?
Fog is very good for like, I believe Mrs. Todd mentioned that she'd like to be able to back up some certain installations that she had and then redeploy those later. That would be an excellent way to do that because they pull very quickly, they'll redeploy very fast. So it's good. I think Fog could be a very useful tool on imaging server, like in a multicast environment, like in a multicast that you need to do, like it's very fast. If you need something done very quick, Fog will take care of it. And it works better, I would say, if all the machines are the same. So maybe you have like a certain set of machines you want to do, that would be better than Windows deployment. Because Fog has Active Directory integration available with it, so all the hosts can register what they need to be in Active Directory. It can, it has snap-ins for installation of like Microsoft Word that's like on a shared drive or something. So it can do whatever it's not built into Windows, it can do those with these plugins that are available. So unless you want a clean, fresh install, Windows might be better for that. But Fog is very quick because it's a clone versus a network image boot. So in my opinion.
So did you actually use WDS to capture any images, or did you just use the standard installation?
I use the standard installation. I hadn't captured or made any custom images. That's something I'd like to get into and look into. So I know we do that here. We have like several different sets of images, like for different classrooms or staff or something. But I didn't.
Did you do anything with multicasting for WDS?
I haven't tested multicasting WDS or on the Fog server. I know they both can do that. I only had 2 hosts to work with at the time, so I don't have much room. But believe it or not, that big lab is pretty much full of stuff. Not a lot of room for hosts, and have them all have a keyboard and mouse.
Did you set the WDS server up on a virtual machine, or did you use a physical machine?
It's a physical server.
And so did you have it running DHCP on that, or were you getting that from a different service?
I have DHCP and DNS running on that pfSense router, actually.
Okay.
So I didn't have to make any special rules for forwarding all that traffic to it, actually. The only special DHCP or network booting I had to do, I enabled it on the server, the pfSense router, but I enabled it so it could find the Linux boot file. But the Windows one it found by itself very easily, so.
What was most challenging for you in the project?
Raspberry Pi. That thing gave me so much trouble. I thought it'd be easier. Milos was actually, I spent a lot of the summer with Milos and some friends in the lab, and he told me to turn off the servers because they're loud, so I decided to work on the Raspberry Pi instead. And
I knew what's gonna happen.
I spent probably 2 or 3 weeks just working just on that, actually. It was a lot of time on that, because I had to recompile, just restart several times, because it just wouldn't, the first few times, like, it wouldn't even, like, I was able to have like the GPS listed, like on top, but like, it would have a big X by it, and like it had like no delay, nothing across the board. So, but I eventually got that to work that way.
Having used OCS's deployment system a little bit, being exposed to that, and then seeing what you tried to build, will that give a new student somewhat of an emulation of what they're about to enter? Will it be good practice? How do you see that being used in the lab?
I see it as an imaging tool. I mean, just for a person who doesn't know how that works, I see that being I have a keyboard and mouse set up on a KVM switch, so they can switch in between the servers when one's on or the other's on. And so they can actually manage the images, they can copy over new ones and mount it. They can see how it's done on the other side versus the deployment server. We just plug in and then network boot and it works. In there you actually can see what it's doing, and all the correlations are direct. And so maybe I I'd say what threw me off from my experience with the OCS's deployment was it took me a couple hours to figure out the correct syntax for authorizing the use of images because I didn't have a domain set up. And it's just acting as a standalone server.
But that shouldn't cause great, I mean, that should be something, once you explain it, that's a pretty
Yes.
easy crossover.
That's a very easy crossover. And so instead of doing like the host name / your user, you just type in your name, whatever you need to use. So that would be an easy crossover, I believe. So, any other questions?
Is the internship experience one that all CIS majors should have to go through?
I would definitely say yes. You will not get there's not a better way, I don't think, to get that actual experience of what real IT can be like. Like, I'd have no other chance to set up a network, like, infrastructure before. I honestly didn't know how it physically, all the planning that goes into that. So you definitely see what it really takes and all the effort you need to put in, but it's gonna be greater appreciation for how all this works anyway, so. And spending time by yourself trying to do something, you have to learn to be dependent upon yourself too, because you won't always have someone to call and ask, hey, the internet's down, how do I turn it on? So, learn how to do that yourself. That's how you help others in the future, so.
As always, we thank you for your support. Fill out the evaluation, leave it with me, and do your comments that will be helpful to him, and hopefully you'll come back and see us for another intern presentation. Thank you for making an extra effort on an already long